this is our reaction presentation. The balanced chemical equation for our reaction is, our reactants are H3PO4, which is phosphoric acid, and Fe2O3, which is iron 3 oxide. Those are the reactants, and the products are FePO4, which is iron 3 phosphate, which is like the thin rust that it creates where you can just scrub off the rust, and then water, H2O. The balanced equation is 2H3PO4, and it is an aqueous solution, and then Fe2O3, and it is a solid, and then this is the products, and then it's 2FePO4, which is a solid, and then 3H2O, which is obviously a liquid, and the type of reaction this is, it is a double replacement reaction.
The importance of this reaction is iron 3 oxide, when mixed with phosphoric acid, it helps remove rust. And usually you use a sander or something with a large amount of friction and abrasion. But when that does not work, you use some sort of acid, and phosphoric acid is one of those acids. You can use it to remove it from metal items you have, household goods that have rust on them, or also metals that are going to be recycled. And it can also be used, phosphoric acid can be mixed with iron 3 oxide to help prevent rust even before the rusting occurs, and that is one of the most common uses today.
So here are the catalysts of the reaction, and the catalyst is just what speeds up the reaction. So there are many different types of reactions that fall into the criteria of rust converters. Many rust converter reactions are sped up when the pH of the reaction is lowered. So almost all of the rust converter reactions involve an acidic reactant. And the reason phosphoric acid is so commonly used with rust converters is because it's got a very low pH, which means it's acidic. The pH of phosphoric acid happens to be 2.4 pH, which is very low on the acidic scale, on the pH scale, I mean. And it just makes it a lot more efficient when the pH is lowered, and it helps the speed of the product to, go faster.
The reaction between phosphoric acid and iron 3 oxide is endothermic. This means that it takes more energy to create this reaction than it produces. So the bonds that are broken they require more energy than the bonds that are formed at the end. And overall, there's less, the products absorb energy, and the reaction overall takes energy to occur.
So there are lots of safety precautions with the two reactants, because the products aren't as dangerous, because the products are just that thin rust that can be easily scrubbed off. Well, the thin, iron phosphate, and then it's also water, so that's not very dangerous. And then so with the reactants, phosphoric acid, it's acidic, can cause a lot of detriment to your skin, and so that, you want to be sure to wear lots of personal protective equipment such as goggles, face shields, gloves, chemical protective clothing, boots, and an apron, just like this man is. And then with iron 3 oxide, Fe2O3, do not inhale the fumes. They can cause a lot of respiratory illnesses such as pneumoconiosis, and it's very detrimental to your respiratory system if you do. And then wear goggles, because repeated exposure can lead to permanent eye staining, which is very weird looking, I'd say. And then the substance is not combustible unless finely powdered, which is basically saying it's not flammable or explosive unless it's a very fine powder.
A history reaction. The reaction does not have a very deep history. Acids were first known to corrode and remove some substance, and phosphoric acid was one of the acids that was discovered that helps remove rust from iron. Today there's a lot of common household products that have phosphoric acid to help react with the iron 3 oxide or rust, and this was not common to have this household product until mid to late 20th century. And phosphoric acids, it was improved to remove rust because now it's only about 30% of the common rust remover solution, and the others are petroleum-based solutions and other liquids that help make sure the acid does not corrode or do more damage than benefit the rusted solution or the rusted